Everyone, so today we'll look at a very beautiful question called different divisors. This is from Code Forces round 696 div 2. Sadly the rating is only 1000, though I thought like the application of concepts is so beautiful it could be rated some 1200. Maybe I'm wrong, but the approach that I am going to tell you is really beautiful. So the question says that first it just introduces you that what is a divisor. So basically x is called a divisor of y if y module x is equal to 0. Very basic introduction. And then the question is that you are given an integer d, right? And you need to find me the smallest positive integer a such that there are two conditions. One is that a has at least four divisors, right? So basically it has greater than equal to four divisors, and difference between any two divisors of a is at least t. So like if let's say the divisors are a1, a2, a3, a4, so basically any summation you take, like from ai minus 1, if your I goes from, let's say it goes from 1 to n, right? Your I goes from 1 to n. So if you take the minimum of all these quantities, that should be greater than equal to 2, right? So difference between any two divisors of a is at least d, like okay, sorry, not 2, it is d, right? I just assumed d equal to 2 seeing the first test case. But okay, so the test case is given here. So first it says that d equal to 1. So for d equal to 1 you can simply choose 1 2 3 4 as the, okay, no, not 4. So you can just choose 1 2 3 and 6. So basically your 6 will have four factors: 1 2 3 and 6, and clearly the difference is at least 1, which is satisfied. The next test case is for d equal to 2. For d equal to 2 the answer is 15. From like using this, that 1 3 5 and 15 are its divisors, right? So you get this particular number, and this is the smallest integer that satisfies all those conditions. Okay, so now let's look at how do we see this mathematically. So now tell me one thing: we need to form the smallest positive integer a. What does that mean? That means I think if you take the least number of divisors and you just figure out an optimal algorithm, you will be able to do it, right? So let's say your a has one of its divisors has to be 1, and the last one has to be a, like the greatest one has to be a, right? Now we are confused that what these two will be, right? Okay, so now we have studied something called the fundamental theorem of arithmetic, which I think this was taught in class 10, and it used to say that any composite number can be represented this way, that some a power p, like let's say we take some capital Q composite number, and this can be represented as a power p, uh, b power q, c power r, and so on, where all these a b c and all these are primes, right? And p q r are their respective powers, right? Okay, so now tell me one thing. uh, we need two more numbers, right? Now, and the number of factors that we have total is 4. Now tell me, for this kind of a number, can you tell me the number of factors that it has? I'm not sure if you know how to write the formula, but the formula goes something like this: p plus 1, q plus 1, r plus 1, and so on. How does this come? It's very simple. So see, tell me one thing: from this a power p, what are the different ways of choosing? So you can either choose a power 0, you can either choose a power 1, you can either choose a square, and you can choose a power p. So there are basically from 0 to p, there are these p plus ways of choosing, right? For this also there are q plus ways of choosing, and for this there are r plus 1 ways of choosing. So the total number of ways of choosing is basically from the very fundamental theorem of multiplication, we have p plus 1, q plus 1, r plus 1, where all the tasks need to be done at the same time. So this is the formula for the number of factors, right? Okay, so now as we have only two places, so let's take, we have some p power alpha and q power beta, because we definitely cannot have more than that. because then p, q and r itself would be 3 factors and we only have place for 2, right? So this if you write in this form, p bar alpha q bar beta, so our alpha plus 1 into beta plus 1 needs to be equal to 4, which is the total number of factors, right? Okay, so now tell me one thing, that then what are the possible values of alpha? See, this can be 2 and this can be 2, so then your alpha is 1 and beta is 1. Also this thing can be 4 and this can be 1, so then your beta is 0 and your alpha is 3. So these are the two sets of alpha beta that satisfy. One is 1 1 and one is 3 0, right? Okay, so what does that mean? So I had taken a equal to p power alpha and p power alpha q power beta. So it is either pq or p cube, right? This is how a looks like. So then what will be my factors of a? So in one case it could be 1 p q and pq, right? And in the other case it could be 1 p p square and p cube, right? Because p cube definitely has these factors, right? 1 p and p square, and this has 1 p and q, right? So now what is the condition that I need to satisfy? I need to satisfy that the difference at least has to be d, right? It has to be greater than equal to d. So what does that mean? That means your p minus 1 has to be greater than equal to d, so your p is greater than equal to d plus 1, right? So what is my search here? My search is that I already know the value of d, so I know what is d plus 1. So I need to find the closest prime that is greater than equal to d plus 1, right? Then my search is done. But does that mean that my other conditions are satisfied? In this case, not really. I also need to see that q minus p is greater than equal to d, right? And what do I know from my previous case is that p is greater than equal to d plus 1, and I've already found what p is, right? I've already found what p is. So q will be greater than equal to p plus d. So basically you need to find the closest prime that is greater than equal to p plus d. So then you will get q, right? Okay, let me use a bit thicker pen. Okay, so I need to find the closest prime. I need to find the closest prime that is greater than equal to p plus d. So then this search is done. Okay, so then you have p, then you have q, and you can find what is pq. So that is 1a, right? Now what is the other a? The other a is the form of p cube, and that has factors 1 p, p square and p cube. So what is the condition from again the first case? It is the same condition that your p minus 1 is greater than equal to d, so your p is greater than equal to d plus 1. So that means again the closest prime that is greater than equal to d plus 1, the same thing. But do I need to fulfill any other condition? So let's just have a look at that. Okay, see, this thing I already know, right? Okay, so now let's find the difference between these two factors, p square minus p. It is basically p into p minus 1, and we know that p minus 1 is greater than equal to d, which means this is greater than equal to pd, right? And if this is greater than equal to pd, so that definitely means this is greater than equal to d, because p is a prime number and 1 is not prime, so p is definitely greater than 1. It is greater than 1, right? So if it is greater than 1, then this pd will definitely be greater than equal to d, right? Similarly for the next case we can also see p cube minus p square, right? This is equal to p square 1 minus p square p minus 1, I think. Yeah, p square p minus 1, and again p minus 1 is greater than equal to d, so that means this is greater than equal to p square d, right? So if I can just choose the closest prime p that is greater than equal to d plus 1, so my job is done, right? And then I can just take the minimum of pq and p cube, right? So that is the implementation of this question. I believe the whole logic is clear, and it was a very beautiful question overall. So you should definitely try to understand this. Thank you.